Throughout history, we have developed vaccination to protect both humans and animals from a wide range of preventable and potentially serious illnesses. With vaccines, we take advantage of one of the most important aspects of the immune system, the ability to develop immunological memory. This means that once the person or animal is exposed to a particular pathogen, in other words, anything that can cause an illness, they will develop resistance to infection with the same pathogen in the future. Our adaptive immune system contains white blood cells known as T and B lymphocytes. These become activated during the first time or primary exposure to a pathogen. Once the pathogen has been fought off by our body, a population of these T and B lymphocytes, known as memory cells, remain in the individual. These memory cells remain on standby, ready to react quickly when the individual is re-exposed to that particular pathogen in what is known as secondary exposure. The immunological memory helps the immune system respond much more rapidly and effectively than during the primary exposure. As a result, the individual is generally protected from the development of disease symptoms. Now that we know about immunological memory, what about vaccines? Well, it simply means that we generate this memory effect artificially and at an early stage to prevent future disease. This means we inject a weakened version of pathogens, inactive pathogens, or just particular parts of pathogens into the individual we want to protect. In healthy individuals, these vaccine components activate a specific immune response, mimicking primary infection, but weak enough not to cause the development of disease symptoms. For example, the varicella or chickenpox vaccine involves injection of a weakened version of the varicella zoster virus. In healthy individuals, this weakened virus will not cause chickenpox symptoms, but it will activate an immune response. As a result, when the vaccinated individual comes across the varicella zoster virus again, for example from a person infected with chickenpox, he or she will mount a rapid memory immune response to the virus and will not develop chickenpox symptoms. By taking advantage of immunological memory in this way, vaccination prevents and controls the spread of a wide range of illnesses, including polio, smallpox, whooping cough, measles, and the seasonal influenza virus. In recent years, there has been controversy over the safety of vaccination programs. To date, all credible scientific evidence strongly supports the importance of vaccination in avoiding preventable illness in individuals and populations. So there you have it, vaccinations. They trigger our immune system to develop memory cells ahead of time, meaning our immune system is ready to launch an attack as soon as a pathogen enters the body.